Hello everyone, welcome to the lecture series on design and analysis of algorithms. Myself Dr. Siva Ramakrishna from Institute of Aeronautical Engineering, working as assistant professor in the Department of Artificial Intelligence and Machine Learning. Today we continue the discussion on the algorithms. If we recollect, in the previous session, in the previous lecture we discussed about the algorithms, and we have provided a deep introduction to the algorithms, importance of algorithms, most importantly, the basic definition of algorithm from different authors. They are the pioneers of these algorithms. So just we quickly recollect the discussion, and then we will continue the session on the today's lecture, that is algorithms. From the Donald, what we said, it is algorithm is a finite set of rules that gives a sequence of operations for solving a specific type of problem. This is what we said. An algorithm should consist of a specific set of rules towards solving a specific problem. The algorithm is a well-defined computational procedure that takes some values or set of values as input, produces some values or set of values as output. An algorithm is thus a sequence of computational steps that transforms the input to the output. This is one more definition what we have seen from the author Karma. So that is, algorithm can take a set of values as input, and these values are going to be processed through the steps in the algorithm, and finally the algorithm should produce an output or set of outputs. The other definition what we come across is, an algorithm is a finite set of precise instructions for performing a computation or for solving a specific problem. So this is one more definition from the author Woolman actually. So it is consists of the algorithm consists of set of precise instructions without any ambiguity. Each step has a purpose and a definite functionality towards performing, towards defining, or towards solving a specific problem. The other one what we have seen is an effective procedure or finite set of instructions that can be followed mechanically to compute a function or solve a problem in finite number of steps. From this definition, what we observe is, no algorithm should consist of infinite number of steps. The algorithm should conclude or end after certain number of finite number of steps. No algorithm should run indefinitely. The algorithm do accept the input, do take the input, and this input is going to be processed through set of steps or nothing but the instructions, and each instruction is very precise and has a dedicated approach towards solving the problem. That means no instruction or no step is written randomly while designing an algorithm. That is the first takeout we can say. If you define an instruction or if you define a step as a part of the algorithm should have a functionality. The algorithm has a specific purpose in the process of solving the problem, and these number of steps should be a finite number. No algorithm should run indefinitely. This is what we have seen the other day, and we also come across the properties of the algorithm. What are the good algorithms? What are the robust algorithms? I can say good algorithm. We can say good algorithm and bad algorithm easily. The algorithm that do not conclude with a finite number of steps, we can comment it as a bad algorithm. The algorithm should run within a specified amount of time with the specific resources that are available. With the specific amount of resources available, with that it should run and conclude to produce a specific output. So these are the properties we said. finiteness, finite number of steps, definiteness, definitely take some input, it definitely produces an output. That's what input, there should be an input. Very, very rare case you can design algorithm with zero input. Very rare case we can design algorithm with zero input. And the output, there should be an output or a set of output values we can expect once the algorithm process over the set of inputs. And then effectiveness. These are the properties of the algorithm we have seen. Now we continue with the topic called algorithm. So we just revisit the definitions from the authors. We can summarize it as a well-defined computational procedure. An algorithm is a well-defined computational procedure that takes some value or a set of values as input and produces a single output or set of outputs. Now, how to write the algorithm? What are the ways to write the algorithm? Do you think algorithm is nothing but writing in a programmatic manner? Nothing but knowing the language, I can write the algorithm. Knowing the language, anybody can design the algorithm? Not like that. It's an approach. It's an approach. To be frank, program is the next step. Is the next step after your algorithm. First we come up with the algorithm. Then we can design that algorithm with the help of any programming language such as C, C++, Java or Python. Now, in order to implement this algorithm, one should develop a pseudocode. That will give a fair idea about the process, what we are doing, or what is the problem and what is the solution we are going to provide for a specific problem. So let us see the algorithm initially written in the pseudocode level, that is written in a pseudocode which can be implemented in the language, which can be implemented in any programming language. So this is the preliminary step before we implement the algorithm. I can say implementing the algorithm and then designing the algorithm. Designing algorithm requires a lot of parameters to be considered. The way you are going to express that algorithm is nothing but a pseudocode. So here is a simple definition for the pseudocode. What we can see, pseudocode is a notation resembling a simplified programming language used in program design. So this gives the fair details about the algorithm or the steps or the instructions involved towards solving a specific problem. Later we can express each step or each instruction with any programming language. The pseudocode should resemble any programming language. So if I take any programming language such as Java or Python or C, I can implement this pseudocode. That is nothing but our implementation phase, nothing but the implementation phase of the algorithm. Then if we proceed further, let us illustrate some simple examples about the pseudocode. How it looks like. See, this is a preliminary approach towards designing an algorithm. We should have a thorough idea on the algorithm. What is the problem? What is the input? And what are the steps? Now you put it on a paper or put it on a notepad. We need to describe each step. Thereafter, we can implement each step. With any programming language. Let us consider an example. Each pseudocode starts with a starting step, nothing but a starting phase. Let us say start at the step 1. Then it is going to, let us consider some example here. There are three variables. They take some values. Now the problem is, we need to choose the maximum value among the three values. We need to choose some maximum value among the three variables that are having some, let us say, some integer values. So first we need to read the variables. Let us say the variables are nothing but A, B, C. These are the three variables. The three variables holds a specific value, nothing but an integer value. Let us say. First read these variables. Now, in order to find out the maximum among the three variables, what is the basic approach as a programmer or as a designer I need to have? I'm going to compare. Fundamentally, I'm going to compare all the values of the variables such as A, B, C. I need to compare all the values. So comparison is nothing but which is greater, which is smaller. Let us say in the step 3, what I'm going to do, I'm going to bring an if condition, a conditional statement to verify the two values. I want to compare the values of the variable A and B. Let us take the two values initially, A and B. Now put or express a conditional statement, that is, if A greater than B. If A greater than B, then what we are going to say? Go to step 4. So that means we have already compared the values A and B. It is adjudicated that A is greater than B. Now you can give the direction where to go. Now we are in the step 4. In the step 4, if you observe, again one more conditional statement is written to compare the values of the variables A and C. What we are going to say? If A is greater than C. So in step 3, we compared the value of A with B and we made a conclusion that let us say if the value of A is greater than B, now you need to compare the value of A with the variable C. Now what we are going to say? If A greater than C, then finally you are going to say the statement that A is the largest value among the three variables. What we are going to print A is largest. Otherwise what we are going to say? Print C is largest. By means the value of A is already compared with B. Let us take the values of A. Let us say some example. A has 10 and B has some 5. And let us say C has something like 7. First, initially what we are doing? We are comparing the values of A and B. In the step 3. In step 3, we plan to compare. We asked to compare the values of A and B. The output is A is greater than B. Now we compare the value of A with the value of C. Let us say what is the value of A here now? The value of A is 10. Now in this step, that is step 4, we are comparing the value of A with C. So 10 is greater than 7. That means what we are going to say? A is greater than C. That is print A is larger. If fail in the sense, suppose the value of C is further greater. That means suppose if the value of C is, let us say the value of C is 12. If the value of C is 12, now in step 4, what we are going to do? We compare the values of A and C. We made a conclusion that 12 is greater than 10. We made a conclusion that 12 is greater than 10. That means C is greater than A. So in the if condition, if the statement fails in the sense C is greater than A here, then what you can print C is largest. This is what written in step 4. Now if you observe step 3, in step 3 we introduce an if condition. If condition, what we said, if A is greater than B, then we ask to go to step 4 and now compare the values of A and C. Then take the decision, print whether print A is greater or print C is greater. Now in step 3 itself, if the condition fails, that means if B is greater than A, let us take some other values for A and B. Let us take A as 4, and B as 8. Suppose if the value of A is 4 and the value of B is 8, what happened to the condition written in step 3? Failed. That is, if A greater than B, it's a false statement. So what we are directing? Otherwise, if the condition fails, otherwise go to step 5. So from step 3, we will directly jump to Step 5. No need to execute, no need to run. Step 4. That's what the recommendation we are giving in the algorithm. That's nothing but a pseudocode, I can say. Right? So in step 5, what we are doing here? Now, the values of A and B were already compared. The values of A and B are compared. The return statement is false. If A greater than B, that fails. So we will directly jump to step 5. In step 5, we are going to compare the values of B and C. We are going to compare the values of B and C. Let us see. Again, we have one more if condition. If B greater than C, B greater than C, let us say the value of C is 5. The value of C is 5. Now in the step 5, what we are doing? We like to compare the values of B and C only. Now if B greater than C, it's true because 8 is greater than 5. What do we want to say? Print B is largest. Otherwise print C is largest. When the statement B greater than C becomes a false. When the statement becomes a false, we want to say that print C is largest. And finally, we are going to write a stop statement. We are going to write a stop statement. Right. The approach is never, the approach never moves indefinitely. It has a specific number of steps. If you ask me how many number of steps are there, we can say that 6 number of steps, of which step 1 is going to start the algorithm, step 2 is going to end the algorithm. Step 1 is going to start and step 6 is nothing but end of your algorithm. In between step 1 and step 6, in between step 1 and step 6, that is step 2, 3, 4 and 5, the actual logic is being implemented. For the given problem, what is the problem? Find the maximum among 3 numbers. This is the problem. Find maximum among the 3 numbers. This is the problem. To this problem, we are giving an algorithm. If you clearly observe, all the definitions, whatever we studied are going to meet here, are going to merge in this slide, in this particular problem here. What is it? No algorithm is written randomly. No algorithm is written randomly. Sorry, no step is written randomly. There is a specific purpose. Step 2. What is the purpose of step 2? Step 2 is going to read the values of the variables. That is A, B, C. In order to make a comparison, I should read the values. First, I should read the values. After reading, then we can go for the comparison. It's a purpose. There is a purpose for step 2. Similarly, step 3. In step 3, what we are doing? We are initially take the comparison between the variables A and B. If true, what you want to do? If false, what you want to do? Clearly written. Similarly, step 4. Step 4 will activate. Step 4 will activate when the statement that is written in step 3 becomes true. If A greater than B, then go to step 4. It's a purposeful step written. There you are going to compare the variable A with the variable C. Now step 5. If step 3 false, the statement written in step 3 false, then what is the purpose? We move to the step 5. There we are going to compare the value of A, the value of B with the value of C. The variable B is compared with the variable C. And finally, in step 4 and step 5, we are going to print the outcome. Either it may be A greater or B greater or C greater. Right? So if you clearly observe, all the definitions, whatever we have quoted previously, are going to met in this particular example. 2 things are clear. It takes inputs. It takes more than 1 input, nothing but 3 inputs. This approach needs 3 inputs and produces an output. What is the output? The maximum value of the existing variables. The maximum value among the existing variables. It can be A, it can be B, it can be C. One output is going to be written at the end of this algorithm. Right. This is a simple illustration. How can we present an algorithm? How can we write the algorithm? How can we write the algorithm in a pseudo code manner? Whatever we have seen previously, that is not a program. That is truly not a program. With those steps, we can implement in any programming language such as C, Java, C++, Python, whatever it may be. But these steps are essential. Reading the variables, comparing the variables, and then print whatever the maximum value, print the maximum value of the variable. Now let us find the difference between algorithm and program. Do both are same, or is there any difference? Does algorithm and program are going to be meant for the same? Of course, they are all for the implementation or solving a specific problem. I can say that. First, we come up with an algorithm. The algorithm is going to be implemented or designed. The algorithm is going to be implemented with the help of any programming language. If you want to implement the algorithm written with a lot of brainstorm, that requires a specific language. That is nothing but an implementation. These two are very, very essential towards solving any problem. Now let us have a quick review about the comparison between algorithm and program. What is by an algorithm we have seen? See, algorithm is at the design phase. Algorithm is at the design phase and program is at the implementation phase. Once the design is ready, then we can go for the implementation. Without designing, without having an idea towards the problem, then you cannot provide a solution to the stated problem. So what is required here? Algorithm is at the design phase, is at the very initial step, is at the very initial phase of your problem towards giving a solution to the specific problem. And the algorithm is generally written in any general natural language. It does not require any syntax. It does not require any programming structures. Does not require. The way we speak, the general way what we write in any English sentence, with that you can design the algorithm. It's an idea. Algorithm is nothing but an idea. What we have seen the definition, it's all fine. There are many people are coming with the many definitions. If you summarize, the outcome of the definition is very same. It has a set of instructions or rules towards solving a specific problem. No algorithm should go or run indefinitely. There should be a specific output. It takes some input. The input should process. These are the summary, nothing but the summary statements of different outcomes what we can say. Now, the idea is we are trying to compare the algorithm with the program. Algorithm is actually at the design phase or initial approach. It's an initial idea towards solving a specific problem. And now, it is generally written in the natural language, spoken language or written language. It does not require any critical programming language stuff, such as syntax, or that does not require. Now, written in any programming language. What is the program? If you want to implement the algorithm in any programming language, what is required here? You must aware of the programming language. Nothing but the syntax, how to write if condition or flows, how to create a block of code, whether braces are required or not, what are the inbuilt methods, how to create functions. So this kind of stuff is essential in order to implement the algorithm, the designed algorithm. And the person who is designing an algorithm should have a domain knowledge. He should have a domain knowledge, a specific domain knowledge on which he is working. Suppose the problem is towards some medical, the problem is towards financial, the problem is towards object detection. Should have a specific domain knowledge. Accordingly, the algorithm should be developed. Then, what about the programming? If you want to implement the given algorithm, you should be a good programmer. You should have a good programming skills, because the steps are already written. Our instructions are already given. Now the task of the programmer is implement these steps using any specific programming language. Now what we can do at the end of the algorithm design? So once the algorithm is written, what we can do? We are going to analyze the algorithm. It is always required to analyze the algorithm for several parameters such as time complexity, space complexity. You need to analyze how many number of variables are required. What is the execution time? What is the amount of memory or space required while implementing the algorithm when it comes to the implementation? So in the algorithm, generally we need to analyze. We need to analyze the algorithm once the algorithm is done. Now coming to the programming, once the algorithm is implemented in any specific programming language, one should go for testing. The algorithm needs to be tested across the inputs by changing the input values, how it is responding for a specific input. For a particular input, what is the output? What is the outcome of this algorithm? So in the case of the programming, we need to test the code which is supposed to be the algorithm, and it is implemented, needs to be tested and verified across the values of input and output. Everything we need to test. Or is there any bug, or is there any other issues are there? We need to go for the testing. And same thing in the case of the algorithm, we need to analyze. The analysis needs to be carried out in terms of several parameters such as time complexity and space complexity. And further, so the algorithm is having a natural language English. So if you know English and if you have domain knowledge, then you are ready to start with the design. Of course, you must be proficient in the designing and development of the algorithm. So when this ways chooses care should be taken, we should ensure that each and every statement is definite and without any confusion, because we are describing the steps to solve the problem. Step 1, step 2, step 3, like that, without any ambiguity. One should write the sentences in the general speaking language such as English. Graphic representation or flowchart, it's nothing but a pictorial representation of your algorithm, nothing but a layout, I can say. Use different symbols, use different standard symbols, connect them, have a flow, nothing. Block 1 is moving to block 2, block 2 is moving to block 3, like that. You should have a pictorial representation. This we sometimes called as the graphical representation of the algorithm. Needs to be represented for visualization. So the method will work well when the algorithm is small and simple. If the algorithm is very, very small, then we can go with pictorial representation, nothing but we will say flowchart. Have different types of blocks of different shapes. Have a connected graph, connected flow, and how it is moving from one block to another block. And the other one is pseudocode method. So the method should typically describe algorithms as a program. The pseudocode is very close to the program. If you clearly see, there we are writing if A greater than B. If true, what should happen? If false, what should happen? That means some of the steps are going to be written in the programming style. You can use if condition, you can use for, you can use while, or you can use any other programming concepts while developing your pseudocode. And finally, coming to the implementation, is always made with some specific language such as C, C++, Java or Python. We have to use programming language to write the algorithm, to implement the algorithm, I can say. The algorithm is designed for, the algorithm is implemented for a specific problem using the language. So this is about today's lecture, and in the next lecture we continue further with the pseudocode convention while handling a specific problem. We will consider a specific problem and we will come to the algorithm perspective and we will try to design an algorithm for a specific problem. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.